when we think about an instrument, we think about something that's fixed and it's in one place and that's where it measures. But you've got a system here that does something a bit different. Tell me about that.
Yeah, so here we have a unique combination of instruments, so covering both in situ and remote sensing observations. And the unique thing is that we can do it while driving with this nice car.
So there's a van behind us.
That's a big van behind us. And of course, with that, we are able to get an idea on horizontal gradients, both on the bottom and also higher up in the atmosphere.
So where on the van do you measure?
So we have an intake tube on that roof, and we have also a MOOC telescope also on the roof.
Right.
So
the roof is the critical place. Right.
The roof is the critical place, yeah, where we suck in the air, and also we get the spectra to analyze for different atmospheric trace gases for species. Most of them are relevant for photochemistry, ozone chemistry in the atmosphere. Yeah, so that's the reason that that's something we put everything on top of our truck.
Can we go and have a look?
Yeah, sure. Okay.
It just does sway, doesn't it?
Yeah.
So here we are on the top. What's the important bits here?
Yeah, the most important bits I think is this tube. With this tube we are sucking in air, and this air is split up into different directions and sucked into different instruments, analyzing, for instance, for nitrogen oxides, for SO2, for ozone, and a lot of stuff more.
So it's being sucked in the sides here, and then up and down into the middle of the van.
Exactly.
And then, so that's gases that you're sampling directly, and what else have we got here?
We are also analyzing for black carbon, so for soot. Yeah, moving to this instrument, that's a telescope of our MOOC, so-called MOOC instrument. MOOC is standing for multi-axis differential optical absorption spectroscopy, and we are just measuring spectra, stray light spectra in the UV and the visible, and we analyze them for different trace gases.
So this is giving you gases a bit, thing is gases here.
That's really gases down to the bottom, and that's something a bit more higher to the atmosphere.
So it's looking up.
Of course, we also get a signal from the bottom, but not very close to the whole instrument, because that depends, of course, on viewing conditions. Like today, we have a range of up to 15 kilometers where we get an information on the different trace gases.
Yeah, and then the last bit, I recognise that's something for measuring wind speeds, right?
Exactly. So in terms of interpretation of the different data sets, both in situ and also the MOOC data, we need, of course, some met observations.
So that's weather observations.
Weather observations, and here we have some standard instrumentation, an anemometer for doing measurements of the wind speed and wind direction, and we have temperature, pressure, and everything on.
So all of these things, while the van can be driving, and these can all be measuring as you're moving?
Not all the different things, of course. For the wind speed, it does not make sense while driving. So we are not able to put it up when we are driving, but everything else, in situ observations and also MOOC observations, we are doing also while driving,
so
which is really a big benefit. Yeah, as I told you, these horizontal gradients are also quite important in terms of when we are thinking about satellite validation. The new satellites have a better resolution, so we can really detect also some areas where there's a lot of pollution going on, and it's quite important to have an idea if this is really true, if this is also supported by measurements on the surface.
So a wind speed measurement isn't much good down there. So this doesn't stay there when it's operating, right?
Exactly. So there's a standard of a height for doing met observations. That's 10 meters. So that's the reason that we are putting it up.
Okay.
So let's see if it works. It's very slow sometimes, but with this antenna we are getting information on shippings.
So it's actually detecting, so the sensor, the instruments on the ships
Yeah,
that are
because
telling where they are.
all the ships are forced to send out a so-called AIS signal, automatic identification system. So we get information on the name of the ship, on the lengths,
Yeah.
how powerful the ship is, and where is it heading for, if it's heading to Singapore or whatever.
And then you can measure how much pollution it's
Exactly.
generating.
So with wind information and with our measurements of, for instance, nitrogen oxides and SO2, we're able to really identify which ship is responsible for which peak.
So this is the weather station going up to 10 meters.
Yeah, because that's the standard position for weather observations, for met observations.
So we've got wind here.
We have wind direction and wind speed here, then we have temperature and pressure inside there, humidity of course on top. Yeah, so that's what we have on this mast. In addition, we have also some information on the radiation, on the total radiation going on with this one.
So, and then all of these, so the cables and the intake, they're all feeding back down into the van. So that's where the real analysis
Exactly,
happens.
yeah. So we are collecting all the data with several computers and analyze them, some of them in real time inside the truck, and some of them we have to analyze later in our office.
We've looked at what there is up here, so should we go down to where the data goes?
I think that's a good idea.
Okay, all right. We've got an example here of the sort of data that all of that's measuring. Tell me what we're looking at.
Yeah, on the screen I put a typical example when we are talking about shipping emissions. So that's a short time series for 1 day, 8 hours of 1 day for the measurement site in Bremerhaven, close
So
to
we've
the
got
harbour.
4 o'clock in the afternoon here,
Exactly,
and
yeah.
midnight
And
is up there.
to midnight, so 8 hours. And what you can see here are different types of peaks for nitrogen oxides and also for SO2 in green, so nitrogen oxide in red, SO2
So the
in
nitrogen
green.
oxide here is kind of low, and then there's these little...
Then
so
we
what's
have
causing
really,
those
really
spikes?
steep peaks to really reasonable high values, and that's something we get when a ship is passing.
So one ship
that's
does
all,
that.
Every peak is related to one ship.
And what's this line along the top here?
That's ozone, and that's something which is also typical. Then whenever you have high peaks of NO, then ozone is going down, because you have the reaction of ozone with NO to NO2 plus oxygen. So that means with every peak you would expect also a decrease in ozone.
So that's interesting that not only a ship doesn't just put stuff into the atmosphere, but that chemistry means that other things go down. And it's very quick, isn't it? Because that's what.
Yeah, that's a quite quick
5 or 10
reaction.
minutes.
Of course, that does not mean that in general the ozone would not go up again. So that's really a very fast reaction which is going on. And for the whole story of ozone chemistry, of course, you need much more information and also much more time. So it might happen that you have later on something like high ozone, which is also related to human
For
health.
other reasons. And how far away were you from the ships here? I mean, was this 100 meters?
That's a couple of 100 meters
Right.
in this case. So we are quite close to the shipping lane. But we have also did some measurements much more far away from the shipping lane, so something like 5 to 6 kilometers.
The thing that strikes me is that there's all these very small patterns, like a single ship, you know, one road. All of these are changing local patterns very strongly, and this van lets you measure those. But then the satellites can see the big picture.
Exactly, yeah. So for the satellite, of course, we are also able to see shipping lanes, but only if they are far away from other sources, and of course that's not the case in our area. So in northern Germany we have a lot of different sources of emissions, industry, ground traffic. So it is really difficult to discriminate the different sources, and of course with this measurement that's just one possibility to get a better overall picture, a better idea on really the strengths of the different sources.
And it's so clear, isn't it? It's brilliant.
In this case it's really clear. So of course that's not always the case when the wind direction is not very favorite, then it takes a bit more work to find out the impact of, for instance, shipping emissions, but it's possible.